Okay, so I'm going to begin talking about something that is this idea of standardization. We see it in a lot of different areas. We have it in language. We have it in things such as the nuts and bolts of manufacturing. There was a point in time when the threads on screws were not standardized. And eventually we got to a point where someone created a standard process so that engineers could use the same type of screws through all things. And there's even a standardization on how hot something can be, as well as how painful something can be. So we have this concept of all of these different types of standardization. We have measurements. We use the metric system, a lot of people, for temperature, for distance, for weight. And unfortunately, not everyone uses this metric system. I'm from the United States, and for some reason, we're still on the imperial system. So we use pounds instead of grams. We use inches and feet instead of meters. We use all of these weird units that aren't necessarily standard. And normally, this is not a problem. The only problem is when you're working with people who don't agree on the same standard. And an example of how this happened, or a situation that arose, it was back in 1999. I want you all to think about this. You've worked on a project for years. You've worked late nights. You've worked many hours. And there's millions of dollars that have been put into this program. And you're here on the NASA space group working on an orbiter that is about to land on Mars. So you're in the control center, you're sitting there, you're watching as it slowly approaches Mars. But the problem is, it's not slowly approaching Mars. And this is perhaps the first time that there has been a recycle program on Mars, where we began to take apart satellites into those small pieces. Basically, what had happened is there was a difference between the metric system and the imperial system. NASA uses the metric system for all of their scientific calculations, but a contractor that they used the imperial system, and there wasn't any communication between the two, and so the standard wasn't the same. So I'm John Bott, and I'm here to talk about atomic design theory in practice. And what that really means is we're going to talk about a way to hopefully avoid these type of issues, specifically with design on mobile. Just a note, a lot of my history has been working with iOS and Android, so you'll see a little bit of both. But the concepts... Microphone's dead. Do we have any other microphone? Or I can speak loud if people can hear me. Okay. We'll do this old professor style. Where was I? So the concepts that I'm going to be covering have been concepts that have happened or that have been that you can apply in both web and any mobile iOS or Android type application. And these are the different pieces that you really need to think about as you start to put together a design system. We'll talk about what a design system actually is. What is atomic design theory? We'll talk about why you might want to use it, who you need to coordinate with, and how do you get started in this whole process. And then at the end, we'll talk about some challenges and where you might face them and what you can do to kind of address them. So, no worries. I think the battery's dead. So, what is atomic design theory? There's a couple of pieces to this. Well, there's really the pieces of it and the tools that you will need to make. And the pieces are just like what you learned in your first biology class. They're pieces that grow in complexity. We start with atoms, moving to molecules, and then organisms, and then there's something totally different called templates and pages. But the other thing that we will talk about is the tools that you will need to make to be successful with your design system. So to begin with, just like in biology, we have the atom. The complexity of the atom is very low compared to molecules. Molecules are made up of atoms, but it's the next level up of complexity. If you go further down, you get into this idea of organisms, which is just basically life built up of molecules. And the important concept of this really is that idea of the complexity. If you look to the right of the screen, the things on the right are composed of the things to the left of them. And the design system is the same type of idea. Pages are actual views or activities, and templates are just this idea of similar views that you might use. So you would have a sign-on screen and a sign-up screen, which are very similar concepts, but the actual implementation of them is the pages. And then the pages are made of the ideas of the templates, and the templates are made up of the organisms. And then the organisms are made of molecules and atoms. But I haven't really told you what any of these are. So the easiest way to go into what these different things are is to talk about a style guide. And really, this is the first tool that you will need to create in order to be successful at a design system or at atomic design theory. And a style guide it's like a visual dictionary. It has all the building blocks that you would have for your app or for your website. It has things in it such as the common language of the fonts and the colors and the spacing. It also has this concept of the buttons and the icons and the controls. It will also have things such as whole pages or activities. And the design system, or the style guide, it limits all the possible UI elements. It contains all the possible UI elements that your application would have. So what a style guide does is it establishes a common language for designers, for product, and for developers to all work together. But let's talk about what an atom actually looks like. What is an atom in a design system? So atoms will have those fonts. They'll also have the colors. They'll have these ideas of simple buttons. They'll have those icons, and they'll have that spacing. The same type of thing that we began with the design system. Now, for Android, we've got it really easy. We can just create styles and themes in XML. On iOS, they're not as lucky. Molecules are built up of those tinier components into these larger components. So molecules will have these things such as button groups. They'll have text fields with icons, group controls, tab bar controls, and that's really it. It's like the next tier up of complexity. Now, you can't really just make an application of these pieces because no one's going to download your app or use it because they don't really do anything yet. So the next step is to move to our organisms. And organisms are going to be these larger pieces, such as the sign-in panels or the sign-up panels, the register panels. It'll also have things like calendars, dialogues, and basically other navigational pieces. Anything that sets a pattern for complex components would belong within the organisms area. Now, not everything will become components or organisms. Not everything will become molecules. But these concepts will help you organize your code from smaller things into more large usable components. So to succeed, our design system needs a style guide from the designers, and it establishes the different levels of this complexity and starts to give us the language that we can use to talk about this, as well as the language for us to code in. So a lot of what we just talked about is really similar to creating a work of art. Here we have a hand drawing from Cream Sherry Art, who happens to work at Mercari, and she makes these really cute drawings. But you can see her going through the different phases of creating a drawing. First, she'll begin with a sketch, and then she'll put in all the lines with ink, and then she'll add colors, and then finally, she'll go in and do final touches with software. The sketch is just the rough idea, and then the line or the ink part is where she removes the messiness of the sketch. She actually will draw with ink and then erase all of the sketch. And then adding colors she'll do by hand, and the rest of it's in software. But the design system is similar to this process. It starts with a style guide, and the style guide is like a sketch of the different elements. In fact, you literally might get a sketch file for your components. So after you've received this design system, it's time for you to solidify these ideas with your designer. You'll want to talk with them about the different things that need to potentially change, and really, I would suggest that you prefer native patterns as opposed to making all of your experiences the same. If you have an application that's exactly the same on the web and on Android and iOS, it typically doesn't have as good of an experience for your users. Now, in this process, there's no stupid questions. You might not like a color. But remember that these people are your friends. They work hard with you. They've poured their hearts into this, and you might want to be a little more clear in your messaging and perhaps a little less emotional. And one thing that you might want to do is help your designers understand more about mobile UI patterns. So in here, we've given a note of, we don't use 2 passwords usually on mobile. It's not a very helpful pattern. And so typically, when people are signing up, they will still put their password once. We won't have 2 passwords fields. So the style guide is the blueprint of what to build. We've worked with the designers on what the atoms, the molecules, organisms, templates, and pages are. We know what pieces that we need to build even before we build a feature. And once we've done that, it's time for us to actually start focusing on the code and hopefully leverage a declarative UI system to make everything work easily. Creating components is really just creating an encapsulated view. And what that means is, just like we have this text view down here at the bottom, we don't know really what's going on inside of it. We just know that we need to give it a context, and that we do have properties that we can use, but we don't have to care about the complexity. Do they access the network? Do they access the database? I don't know, and I don't care. I just want to have the components as easy to use as possible. And Android and Apple have done a really good job in doing this and giving us this really simple API where we don't have to know what lies underneath these controls. A good example of this is declarative UI. This is some code from Jetpack Compose. Who here has had a chance to see Jetpack Compose or hear about it? It's really exciting, and I'll tell you why. In looking at this, I mean, I can show this to my, my 8-year-old son and have him look over this, and he can say, okay, well, there's a column, there's a text field, there's some buttons, and here's some more text. He'll probably say, what's this on-click thing say? And I'll say, okay, well, what happens when you click a button? And he'll say, oh, okay, I don't know what this does. But we know what this does. We just increase the amount with this. But this whole code is so easy to read, and it's so easy to write. So we're told, Bob Martin, one of the big people in computer science, big speakers or big ideas persons, he talks about how we read 9 times the amount of code to writing 1 time. So for every 1 line of code you've written, you've read over the code at least 9 times more. So anything that we can do to reduce how much code we have to read is going to make our development faster. And that's the whole idea behind a declarative UI system. This is what Google has been working on, who knows for how long, but it's in pre-alpha right now. But again, with these on-clicks, we don't really know what's going on inside. Are they using RxJava? Do we need to implement an interface? No, they're just using a Lambda that we can just put in line, and there's no problem. Here's another example of a different design system. Here we have a horizontal view or a horizontal stack. We have an image, we have a text view, we have a spacer, and then some padding. It's easy to read and to understand. And this is Swift UI. Can you see the similarities between this system and the previous one? There's not anything amazing or new about it. It's just making the code so that we can write it easier and read it easier. And we don't even have to know iOS to understand what's happening here. So the goal is to make the components easy to use, just like you can see the text and the buttons on either of these design systems. The text field is an easy to create object, and hopefully we create our objects to be the same. But how do we actually create a custom view? Well, the first thing that we'll do is we'll go in and create our own styles. And these are just built-in Android things where we can name and reuse just like we were using CSS for HTML. So we're creating these items for the different colors, and we're giving it an actual name to use at any point later on in the application. And this is the first thing that we need to do for the design system. We talked about our atoms. This is where some of our atoms begin. It talks about fonts and colors. And then after this, we'll go in and create these an attributes resource file. And all that this is it's just telling us that we are going to have a way of sharing the properties from the layout XML within our code. Here we have the author title or the author name, the book's title, and then some information that we are going to put on the button. And then we can create a layout for our own custom view. In this case, we've created a linear layout. We have 2 text fields and a button. There's really not a lot of magic going on here. And in here is probably where you would apply those styles. I didn't in this example because I wanted to keep this pretty simple. But you create your own layout, and then we need to create the code behind. And I want you all to read over this whole file. I'm just kidding, that is too much to read in one slide. So let's look into this a little bit more. We've created this custom view, and this custom view implements or inherits from the linear layout. And we've created these resource identifiers. This is how we hook in the XML properties into this code. So we do have to create these, and then we are also creating pointers to the different views, the text view and the button. Really not a lot of complicated code here as well. And in the init method, we inflate our view, we find view by ID. We did find view by ID because Kotlin's synthetic properties didn't work within this view. Sometimes they don't work in something like this. But find view by ID works just fine. And then If this is created with XML, we will receive attributes, and we'll pass those on to another method that helps us create things. If we've created this from code, then we can set those properties in the code, and we'll look at those two examples. So to parse the attributes, we just use the context to get the actual styled attributes, and we break all of the different pieces that we will be sending in XML. And so we get the author, the book, and the button text to assign. We do some cleanup, we recycle that array, and then we actually assign the text's value, the author text, the button text, and the book text. And now, in this main activity, we can use this control in XML, no problem. Things to point out is this app : stuff. These are those resource IDs that we talked about. So now I have a way of passing code from my XML, and it is being rendered within the code behind. And this is in the actual designer, and I haven't built, I haven't compiled, and it still shows us exactly the views that I have created. All of these are in just XML, but you can also create them within code. So in here, all I'm doing is creating my custom view with the context. I'm setting some properties on this. I'm even adding a click listener onto the button. And then I'm attaching it to the layout for the main activity. So let's talk about that declarative UI one more time. I showed two examples. We have the Jetpack Compose and we have Swift UI. Now, both are awesome, but they're both years away. Jetpack Compose is, I think, pre-alpha, and Swift UI is in beta. But this concept of declarative UI is not new. There's a thing called Onco. Has anyone heard of Onco before? So Onco is a part of the Kotlin library. So this is approved code. If you go to the GitHub repo, it's actually part of the Kotlin GitHub repo. So it's been around for, I think, a couple years at least, maybe even more. And all it's really doing is giving us the ability to change the code on the top left, which is just Kotlin code, down to this way readable declarative UI code on the bottom right. We know that it's a vertical layout. We have some edit text. There's a button that says hello, and when I click on it, I give it a lambda. So declarative UI is just a concept that makes it so that you can make your code more readable. But Android also has way readable XML. I mean, yeah, I don't like looking at all the Android : stuff, and I wish there was a little more spacing with the color, but I can tell immediately in this layout there is a text view, and a button. And some layouts get a little more complex, but in comparing this to iOS, this is how much code we use. There's like 80 lines of code. This is just to render this view in the upper left, which is 2 text fields and an image. So I feel like Android is a lot further ahead as far as readable XML. And this is why Swift UI is so exciting, is developers on the iOS side can look at this and actually read what the code is doing, as well as see what the designer already gives us in Android Studio. The code is rendering, even when you don't have to compile. Also, at Ancestry, we've created a library for iOS. Again, you don't need it as much on Android. And it's called Fractal iOS. And it's a way to have similar syntax for your declarative UI. So if you were doing any iOS projects, maybe you should take a look at this. I am. I think it's fantastic. And we've talked about all the different options that Android has. Maybe in a year or 5 years, depending on when Google actually moves it out of beta or alpha, we'll be able to use Jetpack Compose. But right now, we can use Onco, or we can just write XML, and we've already got a really good design system. So we've talked about what atomic design theory is, we've talked about the different pieces, and we've also talked about the tools that we need to create the style guide, the component library, and the declarative UI. So why would you use an atomic design theory or a design system? There's lots of really great reasons. For me, the stop repeating yourself is a big deal. How many times have you created something and then had to copy code from a previous view? We do this all the time. I do this all the time. It also gives us the ability to start applying a real brand across the application. As you start working for bigger and bigger companies, not every designer is able to communicate what they're doing with other designers. But if you have that style guide in place, you start to make the brand more solid. Imagine if there was like many different images of Apple at Apple, or many different images of a droid at Google. It would be very hard to tell which one was really Google stuff and which one was someone else's. But another benefit is this ability to rebrand easily. When you start putting things in the design system and you start using themes and styles, you can rebrand really easily. And then we have that common language. You can fast prototype, so you can help product do user testing by creating actual applications quickly when you have a design system in place. And probably the biggest thing for me is I don't have to pixel nudge anymore, meaning I don't have to compile the app and then decide to move the view over 2 more pixels, run it again, move it down 2 pixels. With the design system, each component has already been rendered the way that the artist or the designer approves. So who do we need to have on board? We literally need everyone. We need the designers, the product, and the developers. And we'll talk a little bit about their different roles in all of this. But the important piece is that we get all the stakeholders on board. I can't emphasize that enough. For the designers, they need to create and use the style guide that they need to create, and they need to use the style guide. I keep saying that, but sometimes the style guide gets created, but then it's already out of date. But the designers are responsible for establishing basically the direction of the whole application. So if they don't have a dictionary of views of UI that they want to use, then we're going to have a lot of deviations within the application. And also, we need to help designers to catch this vision of the reusable UI library. Hopefully, they are already doing this. Some are, but our job is to make it easier, make this whole process easier for the designers, as well as to help them understand the style guide, why we want to have the style guide in place. Every large company has it. Twitter, Facebook, Airbnb, Google, the list goes on. A style guide is a must. And for developers, we have 3 main tasks. We need to make the custom views. We need to use a simple API. I'm suggesting declarative UI. And we need to agree as a team to use these components and not just do everything our own way, our own custom way. Hopefully we've separated all the data layers, network layers, and business logic out. But it's really important to get everyone on board. Otherwise, the design system will not succeed. Imagine if I made my own money. Would you buy my money? Well, I've got 1 person. Can I have 2? Can I see 2? So if I made my own money, no one would use it. It's like this with the design system. If we're all making our own money, no one's going to accept our money. Though I really might make Bott coin. And the last people who we need on board is product. Obviously, we have to justify the point of this. We have to sell that we will increase development speed and make the product better by creating this design system. And we need their buy-in to create this. But also, we need product to use to conduct user testing on new features before we develop them. And we can help them do this really quickly by prototyping in this design system. So the last thing to talk about are the challenges that you will probably face as you do your design system. And I put in here a minimum API surface area. We talked about keeping it simple. Try and focus on that. Hopefully you are already isolating your database and your network layers. You should, I would think, be using some sort of MVP, MVVM, some Viper, some sort of architecture within your Android application. And the focus here is we need to value now, not perfection. We can't anticipate every direction that the application might go, but we do know what we need right now. And realize that this is an ongoing process, that integrating new components, we will always be making new views to go into this design system. Just like our job will never be done in developing, it will never be done in building out this design system. But hopefully, we can build enough components to make everyone's job easier and faster. And I would say design for now and adapt as you need. Thank you.